Welcome to this explainer. We're jumping straight into one of the most high-stakes, uncompromising mechanical challenges on a drilling rig, changing a massive drill bit. On the rig floor, literally every component is pushed to its absolute physical limit. We're talking massive weights, incredible torque, and absolutely zero room for error. So let's look at a deceptively simple piece of equipment that prevents a truly terrifying disaster.
13,000. Picture this. You need to change a drill bit. That bit is hanging directly over an open rotary table, and right beneath it is a black hole that is often 13,000 feet deep. That's over 2 miles straight down into the earth. It's basically a void, just waiting to swallow anything that slips.
And here's the crucial problem. You have to unscrew a bit that's been torqued up to 30,000 foot-pounds. And you got to do it suspended right over that open hole. If you get this wrong, the bit doesn't just clatter onto the floor. No, it falls all the way to bottom. And if that happens, well, congratulations. You've just guaranteed a phenomenally expensive fishing job before you've even started drilling.
Section 1. Caging the drill bit. So, if you absolutely can't drop it and you're fighting 30,000 foot-pounds of torque, how exactly do you hold this thing perfectly still while spinning massive steel pipe off of it?
Well, rig crews usually call the solution a bit breaker. It's essentially a heavy steel plate with a shaped recess machined right into it, designed to perfectly match one specific bit's cutting structure. You just set the plate in the rotary table, lower the bit into it, and boom! The bit physically cannot rotate. It's completely locked in.
And this brilliantly illustrates the core concept here. Normally, to unscrew pipe, you need two opposing forces, right? Like huge tongs gripping smooth steel. But a drill bit doesn't have a smooth surface to grip. It's all irregular cones and sharp teeth, so instead of gripping it, you cage it. The breaker's profile locks the cutting structure, and the reaction torque runs straight down through the plate and into the rig structure. The bit's own jagged shape literally becomes its wrench.
Section 2. Every single bit change. Let's take a look at how this heavy plate is applied in daily rig operations.
This process happens for every single bit change, whether going in or coming out of the hole. The breaker acts as the anchor for breaking out the old bit, for sure, but it also holds the brand new bit while you make it up to the correct torque. In practice, a rig actually carries several different breakers, because each one has to perfectly match a specific bit type and size. If you grab the wrong breaker, it either won't seat properly or, way worse, it seats badly and violently slips under all that immense torque.
Section 3. Absolute rules of safety. Because we're dealing with tens of thousands of foot-pounds of torque and a 2-mile drop, the safety procedures here are completely unforgiving.
The absolute, non-negotiable rule on any rig floor is to cover the hole before the bit ever comes off. Crews use a slip type or solid plate cover over the rotary opening for every single bit change. The logic is simple enough. A drill bit weighs anywhere from 60 to 150 pounds. If anything slips, it needs to land with a thud on solid steel, rather than tumbling 13,000 feet down to the bottom of your well.
But dropped objects aren't the only hazard we're looking at. As the bit is lowered into the breaker plate, crews instinctively want to reach in and guide it by hand to align the cones. You never do this. That heavy steel gap closes with tons of downward force and absolutely zero warning. Crushed hands are a major classic hazard here. You always guide it with a tool, never with your fingers.
Section 4. The workbench jig analogy. To really get why caging the bit works so flawlessly, let's step away from the rig for a second and think about a standard workshop.
If you've ever tried to undo a stubborn bolt on an oddly shaped cast metal part, you know exactly how frustrating it is. The whole part just spins right across the workbench. The fix isn't grabbing a bigger wrench to crush the part. The fix is building a wooden or metal jig that cradles the part's unique shape, effectively killing the spin. That's exactly what a bit breaker is. And here's the secret most beginners miss. The plate isn't strong just because it's thick steel. It's strong because that massive torque is spread evenly across the entire profile of all the cones, instead of being concentrated on a couple of tiny jaw teeth from a wrench.
So, here's a quick test for you, just to see if you've got the mindset of a driller. You're on the floor, you need to change the bit right now to keep operations moving, but you can't find the correct breaker for this specific bit size. Can you just improvise? Could you just grab the bit body with the large rig tongs and bite down hard?
The answer is absolutely not. A bit body is irregular, it's heavily hard-faced, and it often has delicate nozzle ports exactly where the tong jaws would sit. If you try to bite it, those tongs are going to slip. You're either going to destroy a very expensive drill bit, or worse, those slipping tongs will violently release tons of stored torque right into the crew standing inches away. If there's no breaker, there's no bit change. You go find the right plate.
So, as we wrap up this explainer, let's look at the big picture. We've seen how the breakout block abandons the idea of gripping, and instead, it cages the bit. We've learned you must always cover the open hole and keep your hands totally clear of the crush zone. And we've seen exactly why spreading torque across the bit's geometry is infinitely safer than trying to improvise with tongs. Protecting a multi-million-dollar well and the hands of your crew all comes down to a single, brilliantly simple, shaped steel plate. Which leaves you with this provocative thought to take away. In an industry defined by massive horsepower and incredibly complex machinery, what other brilliantly simple, zero-moving part solutions are hiding in plain sight, quietly preventing disasters every single day?